The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. I want to thank you all for joining us today for our Webinar Wednesday series. My name is Kelly Hall, and I'm a marketing coordinator for ALS North America. Our presenter today is Nicole Bryson. After completing her undergraduate degree in chemistry at St. Lawrence University, she worked as an analytical chemist in the pharmaceutical industry. In 2000, Nicole proceeded to complete her MBA in marketing from Pace University in White Plains, New York. She has been working in the environmental industry for the last 15 years and has specialized in air and vapor sampling and analytical methodologies for more than 10 years. Now she is the technical sales manager for the ALS laboratory in Simi Valley, California. Today, Nicole will be discussing the characterization of renewable natural gas sources. During this presentation, please use the Ask a Question feature to ask any questions. All questions will be answered at the end of the presentation. Nicole, thank you for your time today to deliver this webinar. I will go ahead and turn it over to you.
Thanks very much. Well, thank you everyone for joining our webinar. As Kelly indicated, we're going to talk about characterization of renewable natural gas sources. So today we're going to talk a little bit about just the regulatory environment and why this is of interest. We'll talk about new requirements and parameters. Then we'll move on to sample collection and analysis, and then conclude with shipping considerations. So landfill gas and digester gas and other sources of biogas have been sampled and tested for a long time. And the sampling and analytical methodologies are pretty well established and familiar to most people in the industry and the practice area. However, with the growth and evolution of gas to energy applications, gas is being tested for a lot of things that it was never tested for before. So just to get us all on the same page, when we're talking about biogas and RNG, biogas made from organic sources through anaerobic processes typically contains anywhere from 45 to 65% methane. And typically we're talking about landfill gas or digester gas. And these both have sources like municipal solid waste, sewage sludge, yard and crop waste, food waste, and manure. This biogas is now being treated to remove moisture, particulates, contaminants, and other gases to boost the methane content to greater than 90%. And this is typically for pipeline injection. So years ago, we were seeing these kinds of industries and these sources being utilized at the facilities, like at the landfills themselves, to power their own turbines or their own, energy sources. But in the last few years, we've really seen a growth in now taking that biogas, purifying it, cleaning it up, and selling it back to the grid for injection into the pipeline. And this resulting product is referred to as renewable natural gas, or RNG. So we're familiar with a number of parameters that have been requested for a long time that are pretty typical things to look for in landfill gas or digester gas. These include parameters like methane, non-methane organic compounds, fixed gases like hydrogen, oxygen, nitrogen, carbon monoxide, CO2, sulfur compounds, BTU, VOCs. But in the last 5 to 10 years, as a laboratory, we've really seen a growth in requests for additional parameters such as these. These include things like siloxanes, whose presence in the gas stream can negatively impact the efficiency of the turbines. We're also seeing increased desire to characterize the gas for metals, ammonia, biologicals, semivolatiles like NDPA in particular, or PCBs and pesticides, or other hydrocarbon characterization. As an example of a specification that we've seen quite commonly at our laboratory is this table. This table comes from Rule 21 or Rule 30 here in California, and you can see that it includes both health protective constituents and pipeline integrity protective constituents. So carcinogenic things in the gas like arsenic or VOCs, or things that we might be concerned could negatively impact the pipeline if they were present, like siloxanes, mercury, or the biologicals. So what's the challenge here? Well, one of the challenges is that there's little to no standardization in the sampling and analytical technologies that are being utilized for characterization of biogas, for landfill gas and digester gas. Part of that, I think, is because there's no single entity that's overseeing how we're supposed to do this. There's no risk drivers here. So there's no federal or state or local entity that's looking out for, say, human health risk or environmental risk like there might be in environmental areas. So the drivers here are typically more about protecting the pipeline or, maybe the efficiency of the turbines. So as such, there's really no standardization in the industry at how you're supposed to sample and analyze for these parameters. And there aren't very many of these that are specific for this matrix. Fortunately though, as scientists, we can look to other practice areas where there are methods already established and then modify those for these matrices. So there are methods in source testing, industrial hygiene, and environmental areas where you can use some of those methods and apply those to landfill gas and digester gas to sample and test for them. One of the examples here, as we'll talk about sampling, is that how you collect a sample in air or vapor is a function of the chemical of interest or the class of chemicals. There's no one size fits all approach. So in air or vapor, it's a little bit trickier than, say, soil or water, where a jar or bottle will pretty much get you what you want. When it comes to air vapor, you have to kind of think about what the chemical stability or its chemical class to determine how you're going to collect it, recover it, and test it. So in this case, a Suma canister or Tedlar bag can't get everything. One of those examples would be siloxanes. There previously hadn't been a standard method for siloxanes until just this past September. At that point, ASTM did publish a method that is based in part on the sampling and analytical approach that we have developed at our laboratory at ALS. This is ASTM method D8230. ASTM method D8230 does establish some criteria in that it specifies some sampling media as bags, canisters, or sorbent tubes, but does still leave some options there and that you have those choices. The method also does help narrow what instruments might be used insofar as they have to meet certain QC criteria. So there are still options available to use a mass spec, ICP-MS, or an AED, for example, as long as the detectors meet the QC criteria specified in the method. So our approach that we developed utilizes a sorbent sampling tube. This is an example of our sorbent tube. Here's a picture of it set up at a facility that we were fortunate enough to visit. So you can see that it's connected to the tubing at the top to the sample port. It comes around. Towards the bottom of the tubing, you can see that there is like a bleed-off valve that helps moderate the pressure or the flow from the system. Then follow the tubing to the left and you can see our sorbent tube. And then over at the end is the rotometer that's help monitoring the flow rate. So this is an example of how one might collect siloxanes from landfill gas using the ASTM method that was published in September. An example report from our laboratory would look like this. There's still some variables, even though that there is a method now that specifies some of the criteria for siloxanes. There can still be variables from laboratories performing this method in terms of how many analytes they report, what their reporting limit might be, and what units they might report, whether it's micrograms per cubic meter, micrograms per as silicon or total silicon. But this is an example of a report that, we would provide for siloxanes. Another one of the parameters that we're seeing requests for is ammonia. So for ammonia, again, there's no specific method for sampling and analysis ammonia in landfill gas or digester gas, but there are options available. One method that you could use to sample and analyze would be an OSHA method, OSHA ID 188-164, which uses a sorbent tube. So this is a picture of the sorbent tube. It's a little tube that contains carbon beads treated with sulfuric acid. Another existing method comes from source testing, and it would utilize this impinger. So you would connect that and it has an acid solution in there to collect the ammonia. For metals, you could use a sorbent tube like this for mercury and utilize a NIOSH method, NIOSH method 6009. And then for metals like lead and arsenic, you could use a NIOSH method 7300 that utilizes this filter. Another option would be to use impingers like that, like the ammonia impinger. Here's an example of a modified approach for this collection. You can see how it's collected. It's connected over there on the left. That's a dry gas meter. And then the sampling goes through those impingers, which are filled with solution for 2 of them. And then the laboratory would analyze those impinger solutions. So those are options. So right now, there isn't any entity specifically saying which one you should use or have to use. It seems typically to be up to either the energy provider or turbine manufacturer to make recommendations. Another parameter that is being requested are biologicals. These would be microorganisms that are related to microbiologically influenced corrosion. And this is a list of bacteria or other microorganisms that are being looked for in biogas sources. To do the sampling for this is also an example of, these are pictures of this site. This sampling uses a filter, so this is a stainless steel pressure filter down in the bottom right-hand corner. So you can see the tubing comes from our source and it goes around. Again, it has the bleed off line there so you can help monitor the flow rate. It goes into this bucket that has ice. So the ice helps to, it's a condenser. So it goes through there, it chills it to knock out any moisture, and then it goes into the filter. This sampling approach and analytical approach is provided to us. You know, we partner with GTI to do this testing. So this is a GTI sampling and analytical approach. For semi-volatile compounds, one of the ones that is typically requested is NDPA, N-nitrosodiene propylamine, but we also see inquiries for other, PAHs, PCBs, pesticides. So in order to collect those, we typically provide a sorbent tube. So it's this little one on the left-hand picture, 2B. That great big glass thing is what would be used for other source testing applications. We're using a modified approach and using this smaller sorbent tube. So on the right-hand side, you can see that that's the tube that you would connect using those fittings to the system. And then you collect your sample, and the laboratory would do an extraction of that solvent, of that sorbent, and then do the testing. So the bottom line is there are methods to do this, and we can help you do it. But it does require some planning. In order to characterize all of the parameters, for example, on the California specification, you need 7 different types of media. So the SUMA canister for volatiles, fixed gases, methane, siloxane sorbent tube, a semi-volatile tube, tubes for the metals and mercury and ammonia, and then the biologicals. So it does take some planning, but to sort of coin the slogan of a hardware store, you can do it and we can help. So it can be done. So that's how you might do the sampling and analysis for biogas. Now we'll talk a little bit about shipping. So one of the challenges is that biogas typically has 50 to 60% methane. So that typically qualifies it as a dangerous good according to US DOT regulations. According to 49 CFR, a flammable gas is any material which is ignitable when in a mixture of 13% or less with air. So you'd want to determine then if your mixture, 13% of it would be flammable. If it is, it needs to comply with the DG shipping requirements. As an example, let's say you've collected your landfill gas with a Tedlar bag or a canister, and it's about 55% methane. Well, based on that definition from the CFR, 55% methane, 13% in ambient air is 7% methane, which falls in the flammable range for methane. So your options for that, if you want to ship that to your laboratory, they allow you to ship up to 1 liter of a non-pressurized gas in an exemption shipper via cargo, or you could ship it via ground. An exemption shipper, an example of one, looks like this. So let's say you have a 1 liter Tedlar bag. You would take the Tedlar bag and put it in that can. The can goes in the box goes in the box, and there's packing material that goes around it. This particular box has special labels that go on it and special paperwork. But using this exemption shipper, you can ship up to 1 liter of non-pressurized flammable gas via cargo. So, the trade-off is that a Tedlar bag is pretty cheap, pretty easy to use, but it would probably require this exemption shipper and the dangerous goods documentation from your carrier, from UPS or FedEx. Another option could be to use a canister. If you use a canister that has, say, 55% methane, one of the things that the laboratory can do is, after it's clean and QC'd and evacuated, is to partially fill that canister back up with helium. Helium is inert, it does not interfere with the analysis, and it dilutes the methane out of the flammable range. So the dangerous goods shipping isn't required. So you can use a 6-liter canister, collect the sample, it's diluted with helium, and then you can ship it normally. Ultimately, it is the shipper's responsibility to properly characterize and ship their items. So confirm this approach and calculations with whomever on your staff might be DOT trained. So really, when it comes to shipping, there's trade-offs. Tedlar bag is easy, cheap, but you have to ship it as dangerous good. A canister is bigger, might cost more, but you can ship it normally. The canister also typically extends the holding time, which can be a concern for some of the constituents. So we'd be curious to know what parameters you might be asked to characterize, how you're managing the sampling. That's something that we do find to be a challenge for some of our customers. And is this creating challenges for you? We are trying to make this as easy as possible for our customers by providing a sampling kit that has all of the parameters, all the sampling materials you'll need to be successful. And you can do it. You just have to plan ahead and be organized. And that wraps it up.
Awesome. Thank you, Nicole. At this time, we will go ahead and open it up for questions. Remember, you can either write out your question in the Ask a Question section or use the Raise Your Hand feature if you want to verbally ask Nicole a question. We'll give everyone a few moments to write those out. We are having a question coming in from Jeff. He asks, does diluting the sample with helium lower the detection limit of the components?
That is a great question. It does indeed impact your reporting limit. So there's trade-offs. By adding the helium, it does elevate the reporting limit. We find that our reporting limits typically are well below any of the required levels. The only one that I think that may be negatively impacted or that we have to do a little something extra for is I think this oxygen criteria here. Is it in this one? There are some criteria that we see that have a very low oxygen level. And in that case, we have to, kind of do something extra, or maybe it's the hydrogen. I think that's the hydrogen. But generally speaking, we can still easily meet any of these trigger levels, for example, in this table, which I have seemed to me to be the lowest ones I've seen come in from around the country, and we can still meet them. So yes, using the helium does dilute it and it elevates your reporting limits, but we're still able to meet these trigger levels and other required screening levels.
Perfect. I don't see any additional questions coming in. Again, if you do want to email Nicole, she put her information there, as well as the email that will get sent out to everyone who participated today will include her information as well. So you'll have that in your inbox by next week. Again, thank you, Nicole, for presenting. Thank you, everyone, today for attending, and enjoy the rest of your week.
Thanks, everyone. Have a great day.